imagine you need advice from people. So you go to two different people. You ask them for advice. And at the end of the day, their advice actually lands up being wrong. Both of them. Now, as time goes on, and you need to ask them for advice again, do you trust those same two people in the same way? Or did one of them lose more trust than the other when their advice was wrong the first time? That's actually a question that's existed for a long time with us humans. Because at some point, we decide to listen to someone a little bit more than someone else. Think about it like in terms of a doctor or your own gut. One friend's opinion over another's. An expert who's sometimes wrong, or a person that you've grown up with and you innately trust that on the topic that you're talking about is probably wrong a lot more than the expert. But what's different now in society is that you might find yourself with a choice between some human or some algorithmic model AI technological thingy. Who do you trust more now? This is kind of new. And today I want to talk about a study that actually put that thought process to the test. And they used real money, so there was some sort of incentive there. But I'll explain that a little bit later. But what they found was quite interesting in terms of trust and our expectations of, I'm going to call it machines and people. Okay, so I'm going to try to describe their setup here. So they got participants and they said, you're given these application files for MBA students who are Masters of Business Administration, but that's not an important part of it. You're basically acting on applications for people to get into a master's program. And then you have to predict how well each student is actually going to do in the program. But there's also an algorithm or model, and as we're going to call it in this thing, a machine doing the exact same task as you, taking the information you were given and predicting how well they're going to do in the master's program. And the real test for you here, and you have to pick one because there's money on the line and you will get extra bonus money from the study if you get it right or you predict the best. And that is, do you trust the algorithm to do it? So all your weight, you're like, you know what, I'm going to go with all the algorithm's answers, or your own answers. And answers are the predictions of how well these students are going to do in their master's program. Now, on its own, it makes sense because you are not an administrator of applications, so you don't really do this for a day job. So you'd probably default to the model because it has access to things, and they have proven to be a little bit trustworthy in our lives today. So with no other information and just that, you say, you know what, I trust the model to wager my bonus money on this. I'm not going to guess. I'm going to go with the model's answers. And this was between 54 and 69% of the time people just deferred to the models. Those numbers are varying because it depends on like the version of the studies, but that's not important here. And these numbers, they make sense, at least to me, someone who does not know, oh my gosh, it's a spider. Where was I? I am not an administrator for these type of things. I do not know how well people will do from a stack of paperwork. So how am I supposed to predict a person's future success in a program based upon that? So a model that has been trained on this and has seen a lot more data and the outcomes will probably do way better. So we go with that. But then there was a part of an experiment that changed kind of everything. Before, some people could make the choice to stick with the model or use their own gut and intuition and say, oh, you know what, you do really well on maths, therefore you probably would do well on this program. They've shown the model actually working in real time, so predicting things and then getting a score of how accurate it was. And those predictions, they weren't flawless. The model still made mistakes. So the very interesting takeaway of the experiment was the participants that watched the machine get a few things wrong. Because that changed kind of everything. Because the people that watched the machine work first before they made their decision became far less willing to bet on it. Because yes, the machine did get some things wrong, but it also got some things right. But what we know from the results is that the machine was far more accurate at predicting these things than the humans. It beat the human forecasters on like every single study. And there was actually a group of people that watched the machine compared to the human forecasters, like every single problem, and saw that the machine was actually performing better. But it did get some wrong, but less wrong than the humans. And what do those humans do? They still bet on the humans versus the machine. But watching a human forecaster make mistakes that were actually worse or happen more frequently than the machine, barely move people's willingness to bet on that person. So if we kind of had to summarize it, there's a lot going on here. And they did like numerous experiments. So I'm kind of trying to give an overarching picture. So I might have missed a few anecdotes here, but I'm trying to get the general trend of what's going on here. People could tell that the model performed better than human forecasters. And when they didn't see the machine make mistakes, so they didn't actively see it before they made the decision, most people were willing to bet on the machine. But the people watched practice runs of that machine and saw that it made a small mistake here. It completely nullified trust like almost instantaneously. And then people were way less willing to actually bet on that and rather bet on the human forecasters who don't know that much. So it was seeing the machine make a mistake that changed trust. Even at the end, when you compare all of the things, overall, the machine performed way better than humans, even though it made some mistakes. Humans made more mistakes. So the easy explanation here is that people expect perfection from machines, but in a different way to what they expect of a human. People still believe that the machine or the model was more likely to produce a flawless answer than the humans, even while choosing the humans anyway. So people know the machine would do a better job, but they still default to the humans. So what the data points to instead is confidence and how fast it drops. Watching the model make small mistakes consistently tanked confidence in it. Watching a human make mistakes, even bigger ones, barely moved the confidence that they had in the human. So what does this mean? Or what does this show? The researchers, they ruled out wanting perfection from the humans and the machine. They showed that confidence in the machine drops a lot quicker than confidence in humans after the same mistake made by both parties. So when they put those two findings together, they didn't actually land on a deeper reason why. A wrong answer costs the machine a lot more than the human. And they concluded and they were saying, you know what? Trying to dig deeper into this is actually super hard. So we're going to leave that work for the next researchers who want to pick this up. Feels like I want closure that I didn't get from this. So when I read about this, I was actually thinking about, I can't remember exactly where it was. It was a podcast or something like that where some person in AI someone was like, what jobs are going to leave in the future because of AI? And this person without a doubt was like, well, we don't really know, but we know for sure, don't go study radiology. And I was like, oh, and because they were like computer vision and understanding that is becoming so good. And this is where this paper made me think about this. Because yes, the AI might be more accurate overall. It's been trained on this kind of stuff. It knows how to pick things out of x-rays. It does actually a very good job of it. It is more accurate in terms of the amount of numbers that it got right to spot things than a human radiologist is. However, what happens if the AI algorithm misses something on the scan? And let's say your friend has the same problem and they go to a human and the human misses something on a scan. Who are you most likely to go back to? Because when I thought about this, intuitively, I was like, if the AI can make a mistake there, then it probably can make bigger mistakes. Therefore, I probably wouldn't go back to the AI radiologist. But I would go back to a human. Why? Why would I go back to a human when it is less accurate? There's something about this humanness here, and it's kind of what this paper showed, is that my trust tolerance for a machine is so much less than my trust tolerance for a person. I don't know if that's just because it's 2026, fast forward 3 years from now, and it will flip. But there's something there, right? I'm not the only one that thinks like that. Clearly, because of this paper. Anyway, it's Friday for me. Check you on the next one.